Assalamualaikum and greetings to Dr. Naziz and our fellow classmates. So our group have chosen the second option for this assignment. Hence, the title of our presentation is Bioethanol Production as Renewable Energy from Agricultural Waste by Fermentation Process. To start, I will briefly introduce to you guys about what is bioethanol. It is a liquid derived from the biomass source to be used as a fuel or electricity supply. So, why bioethanol act as a renewable energy? As I mentioned that it is derived from biomass source, where biomass source is a renewable organic material such as food waste, agricultural waste, textile waste, microalgae waste, and animal waste. So other than that, when comparing the production process of bioethanol with fossil fuel production, they produce lower greenhouse gas emission that will reduce the air pollution. This is because fossil has higher content of sulfur and nitrogen oxides that contribute to the acid rain compared to biomass source for bioethanol production. For our assignment, we highlight the source from agricultural waste, or we call it a second generation bioethanol. As you can see from the picture here, agricultural waste can come from different sources such as crop waste, logistical waste, agro-industrial waste, animal waste, food vegetable waste, and also from edible oil waste. So moving on to the benefits of agricultural waste in producing bioethanol. So first point here is availability. Availability here brings the meaning that agricultural activities around the world has produced a lot of agricultural waste which can be collected to be reused instead of dumping it. So second point is digestibility, where agricultural waste are plants that mainly compose of cellulose and lignin, where it is easily digested to become fermentable sugars, which then be further converted into ethanol by microorganisms for bioethanol production. And then, the second point here is correlated and connected to the third point here, which is high yield of ethanol. So the other benefits are soil structures and soil fertility can be enhanced, as well as soil nutrients can be provided. For example, the natural life cycle starts from decomposition of animal waste, giving back the nutrients to the soil that will act as fertilizer and allowing the plants or crops to absorb the nutrients from the decomposition of animal waste. So I will pass the presentation to the next presenter, Nisa.
My name is Nisa binti Azman, and I will proceed the presentation with bioethanol production stages. Bioethanol production stages involve four main stages, which are agricultural pretreatment, enzymatic hydrolysis, fermentation, and ethanol recovery. Now, I will further explain each stage involved in bioethanol production. The first stage is pretreatment. Pretreatment is the most crucial step in bioethanol production since it enhances the downstream processing of bioethanol. Pretreatment is a process where complex matrix of lignin cellulose is broken down so cellulose is more accessible for enzymatic hydrolysis. In this process, original structure of lignin is disrupted to reduce the cellulose crystallinity, which increases the proportion of amorphous cellulose so it can be hydrolyzed to ethanol easily. The next step in bioethanol production is enzymatic hydrolysis. Enzymatic hydrolysis is the conversion of polymer sugars into fermentable sugars by cellulosic enzymes. This step is crucial because it can affect the quality of hydrolysate, which will affect the fermentation and final product bioethanol. One of the most commonly utilized microbioenzyme is trichodermarase, which secrete beta-glucosidase, exogluconases, and endogluconases. However, microbioenzymes that are used in this step need to improve their stability and catalytic efficiency. The third stage in bioethanol production is the fermentation process. Fermentation process is the conversion of sugars into ethanol by fermentative agents such as bacteria and fungi. These operating conditions are crucial to ensure fermentative microbes can perform optimally. Various technologies are employed in fermentation process of bioethanol production, such as separate hydrolysis fermentation, simultaneous saccharification and fermentation, simultaneous saccharification and co-fermentation, and also consolidated bioprocess. The final stage in the bioethanol production is ethanol recovery. Ethanol is recovered from fermentation broth using a distillation method. During the process, the water content is reduced to approximately 0.5% by volume to produce 99.5% by volume of ethanol. In this process, the fermentation broth is heated to 78 degrees Celsius to allow the ethanol to vaporize and separate from the mixture. Next, I will further explain the role of microorganisms in bioethanol production. Microorganisms function to ferment sugars into ethanol. Ideal microorganisms for industrial production of bioethanol must have several characteristics, such as thermotolerance, offer high yields of ethanol, and resistant towards environmental stressors such as inhibitors. There are two widely used microorganisms in bioethanol production, particularly Saccharomyces cerevisiae and Zymomonas mobilis. Both have high ethanol tolerance, which are 150 and 100 grams per liter of ethanol tolerance respectively.
Hello everyone, I am Sufi Afrina and I will be continuing the presentation with the impact of bioethanol production to the environment and economy. Impact of bioethanol to the environment. Converting agriculture waste into bioethanol provides significant environmental benefits and predominantly positive, as several sustainable and renewable energy sources are incorporated in the ethanol production process. Bioethanol has the potential to significantly contribute to the reduction of harmful gases in global metropolitan areas because it can reduce ambient ozone levels by 20 to 30%. Since bioethanol includes 35% oxygen, it affects how fuel burns completely and reduces particulate matter emitted into the atmosphere, which poses a major pollution-related risk to living things. There is a study that was carried out which found out that diesel fuel mixed with ethanol reduces particulate matter by 41% and nitrogen oxide emissions by 5%. These constituents result in the complete combustion of ethanol and reduce emissions from outflows. Besides that, the impact of bioethanol production is the corresponding decrease of greenhouse gas emissions, GHGE. The most prominent liquid fuel for transportation that doesn't harm the environment with greenhouse gas emissions is bioethanol, which is made from biomass from agricultural waste. This is contrary to the fact that petroleum-based fuel has several environmental risks, thus exposing the positive sides of bioethanol. Next, we will be moving to the impact of bioethanol to the economy. With much discussion about the possible environmental effects of producing bioethanol, there are also a lot of benefits in other aspects, such as the way it can help to create a more sustainable economy. In the upcoming years, there is also anticipated to be growth in the worldwide bioethanol market. The bioethanol sector will become more significant in promoting economic growth as it develops. In addition to opening up new markets and industries for agricultural products, the production and use of bioethanol might encourage growth in rural areas and help build a more flexible and diverse economy. Furthermore, the growth of the bioethanol sector may lead to the emergence of new companies and career possibilities. Apart from that, research and development in complementary industries like agriculture and biotechnology are aided by the growth of the bioethanol sector. This may result in advancing novel techniques and technology that help other economic areas, such as agriculture and renewable energy. Given continued research and development efforts and a growing need for renewable energy sources, the prospects of bioethanol production appear optimistic. The process of producing bioethanol continues to become more economical and efficient as technology develops.
In conclusion, bioethanol production from agriculture waste is a promising approach to meet the growing demand for renewable and sustainable energy sources. Bioethanol gives several beneficial impacts not only to the environment but also to the economy. Despite all the promising benefits, there are still some limitations to be addressed to improve the efficiency and cost effectiveness of bioethanol production from agricultural waste.